Electric utilities today face an increasing challenge in obtaining a full view of the distribution grid. In today's grid, we're starting to see consumer-level devices be contributors to the grid, not just consumers of electricity. So a utility must have a complete view of the grid beyond the edge, what's traditionally determined as the edge, into the consumer level so that the operator can see and operate the grid in an efficient and safe manner. One of the biggest challenges utilities face today is a near exponential growth in the amount of devices, systems, and most importantly, information that's being brought into the enterprise application. It is expected that by 2020, the number of devices in the field will increase from 485 million in 2013 to 1.53 billion by 2020. At the core of Oracle's Utilities Network Management System is a real-time model. This real-time model gathers the information and is derived from traditional sources like GIS systems, planning systems, and other systems providing nominal state information. That model is then augmented or kept in real time through real-time interfaces. These include SCADA, traditional SCADA systems, but more importantly, the Internet of Things cloud service can now tie into this real-time model, providing large amounts of data points that enhance the view of the operator. With this information, the operator can manage the real-time system for both outage management and distribution management functions under one single model, one single view, reflecting what's really happening in the field. As part of this demonstration, we're going to cover two scenarios. One will be a distribution sectionalizing device that is typically not telemetred or monitored by any control system. Through one of our partners, the hardware has been enhanced to include some embedded Java technology and connectivity to the Internet of Things. So as part of the device, this scenario, we have a tree hits a line, the circuit breaker opens, it tries to reclose, it doesn't hold the first time. As it recloses the second time, this device has been configured to open if it sensed a fault and isolate that section of the network. So I'll ask Gabriel to simulate a fault by injecting an overcurrent condition. So here we saw this device operate autonomously based on an overcurrent condition. And in conjunction with our distribution management system, the information received from this device was used to do a short circuit analysis and pinpoint what it expects the faulted line to be by marking this section as faulted. The second scenario is being able to monitor distributed energy resources at the consumer level or at the distribution level. In this example, we're looking at a microturbine connected to the Internet of Things cloud service and bringing that information into the control center so that the operator knows the consumption or the contribution this particular unit is making to the grid. If we look at the grid, we see that we actually model each distribution source in the grid and can see details about that distribution source, like the power that's being produced and the measurements that are being collected from the field. Here we see that the source is the IoT cloud, where traditionally this type of device would have to be configured into a historic SCADA system. We can see if this device is currently producing and how much energy it's injecting into the grid. So here we can see the direction of flow. As this device increases its production, we may see the direction of flow change dynamically, allowing the operator to make accurate decisions when directing crews in the field as to what's energized and what is de-energized. Utilities can now take advantage of all the information that's out in the field and include that into the operator's decision making, enabling the utility to more safely manage the grid.